Well, many of our definitions of GIS include computer systems. I want to point out that GIS, maybe it wasn't called GIS, but the concept of understanding things geographically and analyze them has been around prior to the computers. It's not new. It's just really flourished with computer technology. And the classic example is in the 1800s, 1840s of Jon Snow, not the Game of Thrones guy, but another Jon Snow, who his famous cholera map. And rather than trying to include that in the lecture, I'll include a more entertaining YouTube video that goes over that in detail. But in essence, there was a cholera outbreak in London. And what he did is he went around and tallied up on a map the incidence of cholera and compared that to the distribution of wells where people were getting water, and found that one well seemed to be central to where people were getting cholera. And he went and closed the well down, and that helped reduce cholera in that area, because by looking at the map of incidence of cholera compared to where the wells were, he was able to understand that relationship between cholera incidence and the well. Another example of manual GIS is one that I was somewhat familiar with when I got out of college, or was finishing college or starting graduate school in the early 1990s. I got an internship with the California Department of Water Resources. And since the 1960s, they've been doing mapping out where all the different farm fields are. And so that way they can estimate how much water California needs to support agriculture. And before having GIS, when I got there, they had just gotten GIS, and so they were kind of just starting to use it. But prior to that, they had a manual system of GIS where they would actually, and this was still going on when I was there, they would actually hand draw maps of agricultural fields using aerial photography and these special kind of base maps that have a lot of reference features like roads and canals and everything else. And they would draw out these features, and someone would go out into the field and take a paper map with them and code what the, is it cotton or apples or almonds or what have you. And then what they would actually do is cut the maps. They would actually cut out each little farm field and then separate cotton from apples from almonds. And then they would weigh, I think they would copy it to a special kind of paper first, but then they would cut it and they would actually weigh the weight of each different crop. And they had charts that would tell them, how much the whole map weighed, and if you added up all these pieces of paper and weighed them, how much proportionally that would represent an area on the ground. So that's another example. A third one, I don't have a slide for this, is I had a colleague that I worked with who was a botanist, and she was trying to analyze where these different endangered plants were. And we were looking at trying to use GIS for this work. And I went to visit her in her home office, and she told me, she said, well, I really don't know anything about GIS, and let me show you what I'm doing here. And so she had these stack of paper maps, USGS topographic maps. Let me show you what those look like, because before GIS, move this over here. Most of the map-based work was on, these are called 7.5-minute topographic maps. And they cover an area of maybe about 6 miles by 7 miles. And they have a lot of detail with them. They are what's called an isoline map with topographic lines showing elevation. But they have a whole lot of other features. They show the basics of property boundaries with what's called the public land survey system. They have highways, they have roads, they have urban areas, all kinds of infrastructure. These are the types of maps that would be hand drawn to map out farm fields. And then she was using them to map out where the endangered plant locations are. So they would be on a map like this. This is one for Clovis, and let me kind of zoom in. Some of them are quite old. Some are from the 1960s, and now they have digital versions of these. But anyway, she had a stack of these topographic maps, and she would map out the locations of plants, and she would assign a number to them. And then she would have a filing cabinet with files that had the same number and had information about each of those plants. And so really what she had is the spatial, and then she had a big overview map of where for all of the other detailed maps that she had. So what she had is maps showing the spatial location, and these drawers full of attribute information. The database part existed, but it just wasn't in a computer. It was in a filing cabinet. So these are examples of GIS where you don't actually have the computer system, but you're effectively doing the same thing. It's just not as easy. The introduction chapter, and I think it's worth mentioning here, had a little bit on GIS education and training. And maybe one way to think about this is if you wanted to be a musician, some of this is maybe one way to think about it. If you wanted to be a musician, one thing is training. You actually need to learn how to play an instrument, otherwise it doesn't do you a lot of good. But prior to that, it may be good to have education on music theory, different types of music, and so that you understand the large picture context of what you're doing when you actually learn the instrument. So rather than just learn to play notes, you understand what is blues versus jazz, and what are the different theories of how you play music. So GIS education is important. It's not, I don't want to teach you guys just how to push buttons and boom, a map goes in. We want to learn a little bit about the geographic perspective. Finding, showing, explaining, and predicting geographic patterns, GIS concepts, cartographic principles. Cartography is map making, and there's certain principles about how you make maps to make them effective to communicate with people. And so learning that part of it is very important as well. But in order to do it, you also need training, and it's necessary to get started and learn the tools the same way it's necessary to learn the keys of piano before you can play music on it. And the training is necessary to get started, but you then need to learn how to apply your education to those tools that you're learning. And then the third is experience. That experience, if you're able to, through internships, if you go into graduate school and you work in a lab, and maybe in this music example, that's like being in a band and learning from others, and that's incredibly important as well. The hands-on part of it, both in training, that's where you take your training and your education and learn how to apply it to real world situations. So that's important as well. And just to finish it off, I want to just talk about some misconceptions about GIS. GIS is just a modified CAD system like AutoCAD, where it's drawings in a computer system. The key difference between GIS and a CAD system, where you're just drawing things, is that GIS is tied to database records. It's not just about the visual features, but also about the data that's underlying that in the computer system. Or in a manual GIS, it would be in the file drawers, that there is data associated with that spatial location. Another is that GIS is for mapping only. Mapping is incredibly important in GIS, and most of what we see when we're working with GIS is a map interface. However, so cartography is a science of map making. You use GIS to make maps, but it's a lot more than making maps. It's about the analysis part, where you take different kinds of maps and are able to integrate the data to analyze it and create new information. It's about combining and overlaying and bringing new information together. This is called overlay analysis. And overlay analysis is a key part of the analysis in GIS that we're going to learn about in this class. Later on, we're going to get to it. Traditional paper maps are just as useful as GIS. They're cool, but no, that's, GIS just has a lot more capability, a lot more ability to, paper maps are a pain, and the computer overcomes a lot of the limitations of the paper maps. Or GIS is no different than any other kind of database system. And the key difference is that, so information systems, the IS part, is about transforming data into information. Data is just the stuff in the computer, but information is things, is what you can use to make decisions. So GIS is an information system, but it includes spatial information. And that spatial information is the key difference between a normal and regular database and a GIS.